In the final video of this section, we're going to try and do two things. One is try and pack everything neatly into one formula. And second, we're going to see if our formula can actually handle negative coordinates, and if so, how does it manage this? So if you remember, in the last video we found the length of RP by finding the values of side A and side B, and we found that side A was given by y2 minus y1, where y2 is the y coordinate of point R and y1 is the y coordinate of point P, represented here. So y2 minus y1 gave us this length, and side B was given by x2 minus x1, which meant this x coordinate here minus the x coordinate here. Now, how can we pack this into a formula? Let's look at it. We know that as per Pythagoras theorem, h square equals a square plus b square. Now, what we do have is we have a general formula for a. So we can say that a h square equals y2 minus y1 squared. I have simply substituted y2 minus y1 instead of a, plus, now substituting for b, x2 minus x1 squared. But remember, this gives us h squared. If we want to find the hypotenuse and not the square of the hypotenuse, then we have to take the square root of y2 minus y1 squared plus x2 minus x1 squared. Many a time I've seen students will simply say, oh, we're taking a square root, but we're also squaring, so let's just remove the square root and remove the square. Remember, this entire term we are finding the square root of, which means first we have to add them, and after we have added them, we find the square root. So this, in fact, is a neatly packed formula for distance between any 2 points on a Cartesian plane. Now let's look to point T and ask ourselves the question, how does it having a negative coordinate affect this formula? So let's make a right angle triangle, and let's look first at the y values. So we're going to say h equals, I'm going to put this square root again. Now y2 is 25 minus y1 here is 8. So it is, both are positive values, both are above the origin. So it is 25 minus 8 squared. So far, no issues. Now, how about x2 minus x1? So x2 here is minus 15 and x1 here is positive 15. So over here, what we're going to do is minus 15. We're going to bring down that minus positive 15. Oops, so that's double bracket, whole square. Let's look at what this gives us. So 25 minus 18 is 17 square, plus, now minus 15 minus positive 15. In other words, minus 15 and minus 15 is minus 30 squared. Does that seem right? Minus 30. The gap between x2 and x1 is 30 units. Well, yes, because there's 15 units till the origin and a further 15 units beyond the origin. So the length of this side definitely is 30 units. But how about this minus sign? We have already seen that before. Let's take this as hypotenuse equals the square root of 17 square, I think, is 289, and to this we're going to add. Now, what is the square of minus 30? It's minus 30 times minus 30, which is positive 900, and therefore the hypotenuse is the root of, it is the root of 1189, which at this point you can either calculate it or use a calculator. And if I'm not mistaken, the square root of this is something around 34.48 units. Not a pretty number, unlike previous times, but if you measure it, you'll actually find that this length is 34.48 units. So I just want you to have a look at one thing. No matter what our signs are, as long as we stick to the integer forms carefully, and we will get the correct distance. So 30 units was the correct distance, and once we square that distance, whether it is a negative sign or a positive sign, it doesn't matter, because it will get converted to a positive sign, and in the end our distance will have a positive value.